Right. The last section of chapter 1 is solving linear. What are linear inequalities? What is an inequality? Yeah. Equalities is equal sign. Inequality is less than, equal to, or equal to, greater than, and greater than or equal to. And there's also another one is not equal to. The first thing I have to, you've seen these before. Now, why are they labeled like this? Why is this one less than and this one's greater than? Because we see that the arrow always points to the smaller number. The tip always points to the smaller. But why is this one less than and this one greater than? How do we read math statements? From left to right. So this number is less than this number. This number is greater than this number. So you read left to right. So is that true? No. Sure. Yeah, of course this is false. Because it always points to the smaller. Or you think of an alligator, it always goes for the bigger piece of meat. Is that true? Yeah. 5 is larger than 3. Is that true? Yeah. 3 is less than 5. So these two statements are identical. If I move the numbers, I got to move the inequality sign also. So before we go through these, we're going to go through the whole series of inequalities because there are 3 types of statements that we're going to look for. When we deal with inequalities, we look for sets of solutions, not just one number. In other words, what would be my answer there? If we're only talking about integers, what would be my answer there? What does that mean? You mean, how would you read this? X is greater than 3. X is larger than 3. So what numbers are greater than 3? Yeah. So my answer would be X is equal to the set of numbers 4, 5, 6, and so on. Since we're dealing with sets, we use these bracket thingies. Whatever inside there is our solution, but it's a set of all those numbers. So we're not looking for one number, we're looking for a whole series of numbers. And there are three ways we can represent these. There are three ways to represent these solutions. One, the first way is called set notation. When we're dealing with set notations, that's when we deal with the inequalities. We deal with those. The next one we do are called interval notation. With intervals, we use parentheses and brackets. And the last way is by graphs. So in the grand scheme of things, the parentheses are matched to the strict inequalities. The less than equal to, greater than equal to are matched with the brackets. And on graphs, we represent an open circle as that and a closed circle as that. So what's the difference between these two things right here? But what's the difference between this set and this set? The endpoints, the numbers we're looking at, the endpoints, with these, they're not included in our answer set. With these, they are included. I'll show you what that means in a second. So these are not included, these are included. So like our example we had a second ago, when I said x is greater than 3. The numbers we said were 4, 5, 6. So my answer set would be, it goes from 4, no, it goes from 3 all the way to infinity. Can you ever get to infinity? That's what this means. You can't get to it. If I gave you this, what would my answers include? What would my answer set look like? 3, 4, 5, 6, and 7. Because they're brackets, I can include those endpoints. On a graph, it would look like this. So with that notation, the symbols, let's look at our sheet. take out your inequality sheet, and we're going to go through all these. These are all the possibilities. So the first type we look at are called infinite and closed. What that means is it's closed because it starts with a number and it goes to one direction. It goes to infinity. How would you represent this picture in set notation? Because all these we're looking for are the x's. So x, since it's to the right, it's greater than. Can it include a? It can, because it's included, I can equal it. A. That's what this picture means. I can start off at a and I can go to the infinity. In interval notation, I look at where I start and I end. I start at a and I go to infinity. That's what the picture is going. Can I include a? Yeah, since it's a solid dot, I can include a. That's a bracket. I can never use parentheses, so it's a parenthesis. I can never use infinity, so that's a parenthesis. And then the second one, we have that. These are my x's. So my x's here would be less than or equal to a. Another good thing, if you put the x's on the left-hand side, then the direction of the arrow is what's shaded, or is the direction you're going. If x is on the left, I'm going to, so I'm pointing, and my graph's going to be this way. Now, the interval notation for this one, always read left to right. So I'm going from negative infinity all the way to a. I can never use infinity, so that's always a parenthesis. And since a is a dark solid dot, I can include it, so it's a bracket. Now, these are called infinite and open, which means I can't use the endpoint. So remember, the shaded region is my x's. X is strictly greater than a. I cannot include it. It's strictly greater than a. Look at the shaded region. It goes from a to infinity. Infinity is always a parenthesis. Since that's an open circle at a, that means I cannot use it. I have to use the next number available. These are my x's. So x is less than a.
Will X always be on the left side?
No. We're going to look at some examples where it's not going to be able to, but you can move it to the left side. Again, look at this, the domain of my answers. It goes from negative infinity all the way to a. I can never use infinity, and that's an open circle, so it's parenthesis. The next set of examples we're going to use are called finite and closed. Finite means it begins and ends with a number. and they're closed because both ends are solid dots. Remember, this is my, whatever shade is my X. Two things are going on here. One, X is greater than A, but X is less than B. So X is less than X is less than B. That's the step notation. The interval notation, I'm only going between A and B, so it's going from A to B, and they're both dark circles, so it's included. The next one, we're looking at, it's a finite and half open, half closed. Remember, these are my X's. So A is less than X, which is less than B. Oops, hold it. I forgot these are here. These should be less than equal to's because they're included. A is less than or equal to X, and B is strictly less than X. X is strictly less than B. Look at the endpoints. It's A and B, included, not included. So A is less than X is less than or equal to B, because B is shaded. The bound is A to B. A is open, B is closed. Now I'm looking for the area between A and B. A is less than X is less than B. I cannot use the endpoints. So we have A and B, and they're both not used. Make sense so far? Now we're going the opposite directions. We're going opposite directions. Remember, these are my X's. Here, since we're going opposite directions, we have two possible. First, what does the X represent? When we talk about X's, what do they represent? Yeah, our possible answers. Yes, exactly. Very good. So in all of the previous ones, X can only be here. X can be between here. But now, X can be here. How would I describe that? X can be here. Have to repeat the statement for me. The answer can be here. Complete the statement for me. Where can the answer be? Can it be and or or? In other words, it has to be or, because it's either going to be here or it's going to be here. It can't be and, because it cannot be here and it cannot be here at the same time. So it's or. So we have here is X is less than or equal to A, or X is greater than or equal to B. Let's look at the interval notation. We have from negative infinity to a. It's a parenthesis, and a is a bracket. And then goes from b to positive infinity. Or is only used in set notation. In interval notation, the or symbol is the U, the union. Let's look at the next one. Again, the first part says x is less than or equal to a, because it's a solid dot, or x is strictly greater than b. So the first set goes from negative infinity to a, bracket, unioned with b to infinity. But b is a parenthesis because I can't use it. They're my x's. It goes from x is less than a, or x is greater than or equal to b. Goes from negative infinity to a. It's a parenthesis because it's not used. Union, bracket, b to infinity. These are my x's. So x is strictly less than a, or x is strictly greater than b. And it's all parentheses. Negative infinity to a, parenthesis. Union, parenthesis, b, positive infinity. Three more. How do we represent a point? It's just that number there. How do we represent it? It's a trick question, really. It's x is equal to a. How would you use interval notation? Since it's a solid, and that's the only one we can use, it's that. If it's not a point, that means x is anything else except that. Yeah, I know what you're thinking. We could go x is less than a, or x is greater than a, or we could just do it this way. X is not equal to a. Likewise, in interval notation, since we can't use it, we put it in parentheses. Now, if we're looking at all numbers, we simply write R. And it goes from negative infinity to positive infinity. Those are all the possibilities that we have. One rule is this. When solving inequalities, treat the same as if it was an equal sign. So when solving these things, treat them as we normally do. Example 1. A. 3x minus 5 is less than 6 minus 2x. Solve this and put it in the other two notations. What notation is this? Yeah, if it has inequalities, it's set notations. So we have to put it in interval and graph. So how would you solve this one? What would you do first? What would you do if that was an equal sign? We mean split it.
Combine some each equation. Right, so
But you can't. If it was an equal sign, you're solving for what? X. So you have to get x's to one side. Which x do you move? Always move the smaller to the larger. The smaller is negative 2x. So we add 2x to both sides. 3 plus 2 is 5x. Minus 5 is less than 6. Then get rid of the 5. Get rid of the non-x's. Add 5 to both sides. 5x is less than 11. Divide both sides by 5. So x is less than 11 over 5.
it's literally just an equal sign.
Well, yeah, treat it exactly if it was an equal sign. 11 over 5 is 2 1/5. We'll need that because we'll have to put it in the graphing form, and we have to know where to put it. So here we have it in set notation. So we know that x is less than 2 1/5. Whenever you convert from set to interval notation, it's a lot easier to graph it first. So the graph would look like there's 2 1/5. Is it an open or closed circle? It's open because there's no equal sign. Which area is shaded, left or right? This, and also it's, since the X is on the left, it's pointing to the left. But both, yeah, that's exactly right. So we go this way. And it goes to where? Negative infinity. That's the graph. How do we put this now in interval notation? Look at the graph. It goes from where to where? Negative infinity to positive 2 and 1/5. Infinity can never be used, so it's a parenthesis. And that's an open circle, so that's that. So there are my three answers. B, 13 minus 7x is greater than equal to 10x minus 4. I'll let y'all work on this real quick. So what's my first step?
This one's X.
Yeah, we move the x's to one side. So move the smaller to the larger. So move the negative 7 over. So we add 7x to both sides. Ten plus 7 is 17. Get rid of the 4. So we add 4 to both sides. Thirteen plus 4 is 17. Is greater than equal to 17x. Divide both sides by 17. 1 is greater than equal to x. You asked me, does it always have to be on the left? There's an example where it doesn't. But it's much easier for us if x is to the left. So we can flip this whole thing. Remember, it's still pointing. If you move them around, you have to make sure you flip the inequality. So the graph of this one, I have 1. Is it an open or closed circle? It's closed because it's equal to, and it's shaded which direction, left or right? Yeah, look at the direction it's pointing. It's pointing to the left.
Well, if we didn't flip it, the first one, it would have been on the right or no?
No, it still says 1 is greater than x. 1 is greater than x is the same thing as x is less than 1. So that means my answers are from negative infinity to 1, parenthesis, and a bracket. Those are my answers in interval notation and graphing. Example 2. Find the domain of these functions. What is the domain? What's that? All possible x-rays, exactly. So we have f of x equals square root of x minus 6. And b is h of x equals x over square root of 3 minus x. So we're looking at what are our possible x values? What do we know about square roots? What do you know about it? What can be inside there? Can you have negatives inside there? Can you have 0? Square root of 0 is 0. And it can be positive. So the smallest this number inside here could be is 0. So make it equal to 0. Solve for x. So we add 6 to both sides. X equals 6. That's the smallest x we can use. Because if we put x as 6, 6 minus 6 is 0, we get 0. That's good. Can x be 7? 7 minus 6 is 1. Square root of 1 is 1. So my answer here is x is greater than or equal to 6. Those are my solutions. So this is my domain. X is greater than or equal to 6.
How do you determine the sign? The sign you use?
What do you mean what sign?
Yeah.
This thing?
Yeah.
Well, let's see it. I know that's the smallest I can use because it makes it 0. So I know I have to start off at 6. If I use 7, will that be good? 7 minus 6 is what? It's square root of 1. If I went this way, 5 minus 6 is, I can't go there because I can't have negatives inside there. So I know if that's right, then all of these here are right. So it's going like this. So x is greater than 6, equals 6. Same thing here now. Two things we have to know here. Inside here cannot be negative, and the bottom cannot equal what? Cannot be 0. So we always set inside here. What's the smallest number we can use? Add x to both sides. So 3. Can we use 3? No, because if we have 3 minus 3 is 0, so we cannot use 3. Can we use numbers smaller than 3? No, let's see. 3 minus 2 is what? 1. That's good. Can we use numbers bigger than 3? Right. We can't use those because we can't have negatives. So our answer is this. X has to be less than 3. That's our domain. Now we're going to get with something called compound inequalities. What compound inequalities mean is this. X, reason it's called compound because X can be greater than A and X can be less than B at the same time. When solving compound inequalities, whatever you do to the middle, because you're solving for X, whatever you do to the middle, you do to the other two sides. Example 3. -3 is less than 2x plus 5 less than equal to 7. We're solving for X, right? So what do we have to get rid of first? Concentrate here. This tells you what you're supposed to do. That's where your X is. What do we do first? We're solving for X. We have to get rid of the 5. How? So whatever you do in the middle, you have to do to the other two sides. Negative, my answer is negative. 5 plus 3 is 8. The 5's cancel. 7 minus 5 is 2. No, 2x, I'm sorry. So to get the x by itself, we have to divide everybody by 2. Negative 8 divided by 2 is 4, is less than x, is less than equal to 2 divided is 1. So here we have negative 4 and 1. That's an open circle, and that's closed. X is between here. What would the interval notation look like?
-4.
Comma 1. Is it a parenthesis or a bracket? It's open. Parentheses you cannot use, and this one is a bracket. Example 4. Solve 2x minus 5 is less than equal to negative 7, or 2x minus 5 is greater than 1. Then graph your solution. So treat them both separately. You have to add 5. So we have 2x is less than equal to 7 is negative, 7 minus 5 is 2. Add 5. 2x is greater than 6. Divide by 2 across the board. So x is less than equal to negative 1, or x is greater than 3. We have negative 1 and 3. Is negative 1 open or closed circle? Closed circle because there's an equal sign. And it goes to the left. X is less than. And on the right, is it open or closed? It's open because no equals. And x is greater than 3, so it goes to the right. And interval notation, it would look like parenthesis -1 or negative infinity to negative 1 bracket union open 3 infinity open. Remember, if it's open circle, it's a parenthesis. If it's closed circle, it's a bracket. And infinities are always brackets or parentheses. The last one, here's a word problem, an application problem. Here's what it says. Her interior decorating job, Natalia can be paid in one of two ways. $250 plus $10 per hour, or $20 per hour. Suppose that it takes the job N hours. What values of N is plan B better for Natalia?
So instead of X, they use N.
Right, instead of X, they use N. So we have plan A says 250 plus $10 per hour. Plan B is $20 per hour. For what values of N is B better than A? In other words, what we're looking for here is this. When is B greater than A? So we have to put these in the equations. How do we put A as an equation? $250 plus $10 per hour, right? That's A. And B would be? Yeah, 20 times N. So looking at this, we have 20N is greater than 250 plus 10N. Solve for N. Subtract 10, N from both sides. And then divide by 10. So what's your answer? The answer would be plan B would be better for Natalia if she works more than 25 hours. Remember, word problems have to end with word answers. And that's it. That's end of section 6. That's end of chapter 1. So tomorrow we'll start chapter 2. Any questions?